All right, so to Intro 2.2 in your calculus textbook, there are a number of rules that this activity hopefully will help you uncover on your own, so that I don't have to just give them to you. You're going to uncover them. What we're going to do is this little activity. Okay, so I'm just going to read through it real careful. We've talked about the derivative now as being the instantaneous rate of change, or the slope of the tangent to a curve at a specific point. So what we've been doing in Chapter 1 has been finding the derivative, but we haven't said that yet. That's what it actually was. So we're calling this now the derivative. This activity involves finding the derivative using the formulas that we studied in Chapter 1, but the goal is to compare the original functions with the expressions for their derivatives. And that is the expression of what the instantaneous rate of change would be, as an expression including the original variable, for many different functions, to observe similarities and to try and identify a pattern and to try and uncover the rules that we're going to be talking about. So there's a few steps here. Step 1 is to write down these functions that you see at the bottom of the screen right here. These are the functions that we're going to be dealing with, and I'll just erase the names here. You can relish in the fact that you have, attained more immortality by being on this video. But anyways, bye-bye. Just dismembering all of these names here. Yeah, they're going to stalk you because you're famous now. I know, no one will know who you are. Don't worry. Okay, so I'm going to give you a moment to participate in this activity by copying down these functions. There are 11 of them, okay? And I've hidden the derivatives because we've already done this assignment in class. So I need you to copy down these 11 functions right now. Pause the video if you need to. And I want you, using one of the two formulas from Chapter 1, I want you to calculate the derivative. I'll pause the video and I'll try and show you an example for number 1 because I did that for the class. Okay, so here's the first one. The expression was 3x minus 7, and this is what I want you to do. Limit as h approaches 0, you put an x plus h into the expression. So this is f of x plus h minus f of x all over h. Do that, remember, from Chapter 1, doing all this. The limit is 3. So you would put 3 underneath the expression 3x minus 7. Alright, so step 5, the point of this activity is to try and compare the expressions with their derivatives and try and come up with a pattern, okay? Try and come up with a shortcut on how you could quickly go, because I know right now that this is negative 6x plus 2 for a derivative. I just can look at that and I know that. Okay, yeah, go ahead, double check. Anyways, but the thing is there are shortcuts, and so I want you to, and I think some of you right now are even figuring this out. So once you're done this, okay, I want you to pause the video if you're working along with this video. Pause the video and figure out the derivatives for all these. It may take you a while. If it's just you alone, if you want to skip every second one, I'm okay with that too. But enough so that you can figure out a pattern, okay? And so pause the video, and when you think you have the shortcut figured out, then you can start this video again. Alright, so very good. We've come together as a class. We've shared some observations. Just growing closer through this. That's awesome. Okay, it's good to hear. Okay, no one cares. I'm just kidding about no one caring. I care. I care a lot. So can you have a sleepover at my house? No. Is this recording? Okay, listen. Yes, that's what you sound like. Okay. Let me get to the rules now, okay? Okay, so what our Fantastic Four that came up here to explain the rules, what they said was this. What they noticed was that the degree of the derivative is always 1 less than the degree of the function. That is absolutely correct. That is not a rule. However, that is true. So the expression for the derivative will always be 1 less for a degree. So minus 1. So here's cubed. Look at that. Squared. Here's to the power of 1. Look at that. To the power of 0. To the power of 2. To the power of 1. That is absolutely true. Not in and of itself a rule, but the other thing that they noticed, okay, was the fact that this 6, for example, okay, comes from 3 times 2. And that is absolutely true. The exponent times the coefficient gives the new coefficient for each term. So each term in the derivative corresponds to a term in the original function. Now, I'm going to do this one. Okay, just going to rewrite this. Is that plus 2? Okay. So look at, you take each term on its own, okay, and you deal with each term separately. So if there's 3 terms, you're going to do this same sort of these rules 3 times. And what you're going to do is the exponent times the coefficient to get 6. You're going to rewrite the exponent, and then you're going to subtract 1 from this exponent. It's minus 2 over here? Okay, whatever. Thank you. I'll get there eventually. Hello, eraser. Okay. Okay, so 6x to the 1. Then you move over here, and you know what? This is a plus, so put that plus down. This is actually a rule. Simple, but it's actually a rule that we'll talk about later. So 6x, what's the exponent? 1. What's 1 times 6? 6. What's 1 minus 1? 0. What's the exponent on the x here? 0. What's 0 times 2? 0. And we don't go x to the negative 1, though. Okay, we don't do that. If it's 0, no, there's that. We're done. So, yes, the derivative is 6x plus 6. Very good. Okay, let's do it again to, which was the tougher one here? Well, let's do this one. Let's do a cubic one. Okay, does that work for the cubic one? For this cubic function here, 3 times negative 4, negative 12, x to the 2, right? 1 times 3, so that's minus 3, x to the 0. Or just 3, 12x, negative 12x squared minus 3. Yes. Okay, so there are 3 specific rules I want to talk to you about today that you have uncovered on your own. Congratulations. Here they are. Now, let's say that f of x, a function, equals a constant. The derivative of this function will always equal 0. In other words, I'm just going to write it down what I've been saying. The derivative of a constant term is 0. 5, negative 12, negative 1005.7. Okay? Constant, no variable at all. Okay, capiche? Understando? Okay, that's the first rule. And where do we use that? Let's see. We actually use that here. What's the derivative of negative 4? Well, it's 0. We don't have anything over here. Right? What about negative 7? Well, the derivative here is attached to this 3. The derivative of 7 is 0. It doesn't show up. So there's usually, whenever there's a constant, there's always one less term, right? So the derivative of this constant is going to be 0 all the time. All right. We should talk next about the sum difference rule. There's really 2 rules, the sum rule and the difference rule, but we're going to talk about them both at the same time. Basically what it means is if you have terms, any terms that are added or subtracted together, the derivative of that polynomial will be the sum or difference of each individual term's derivative. Okay? So you might want to rewind the tape there to rewind to hear that one again. But basically it's like this. If we have f plus g plus h, and I am taking the derivative of this expression, so consider this like a polynomial of different terms, f, g, and h. Okay? I'll do an example later. But really, if we're adding these, you can take the individual derivative, and this is an acceptable way of writing this too. I didn't really write this for you yesterday, but you'll see this a lot. That's just the derivative of f, whatever f is, the derivative of it. And so if you have a polynomial or some kind of expression, like this right here, 3x squared plus 7x minus 5. Well, let's do plus because I'll leave the plus so far. So there's my 3 separate terms. Here's f, here's g, here's h, right? If I want to find the derivative of this, and using the notation, brackets with a derivative sign, that means take the derivative of that. then what you do is you look at each term, and you take the derivative of each term and you add them together. So I haven't talked about the power rule because I want to spend the most time on that one, but just suffice it to say that the derivative of this term is 6x. The derivative of this term is 7. So they're added together, so their derivatives are added together. The derivative of 5, it's a constant, that's 0. So that's the sum difference rule. And the same thing, of course, if we're talking about a difference. So here's the difference rule, and it is to be noted, someone just raised this point, that if we have multiplication or division, you cannot just divide the derivatives of each note. You cannot just multiply the derivatives of each note. There's a different rule for that. That's where it gets just a tiny bit more complicated. But as far as sum difference rule, yeah, add or subtract together the derivatives of individual terms in a polynomial. Okay? Any questions? Sum difference rule. Now, let's get to the power rule, which you guys really did a good job of determining this rule. I'm really proud of you for that. The power rule. Now, before I summarize the power rule, I am going to show you what you guys figured out. The derivative of 3x squared, you figured out the long way was 6x. The pattern that you uncovered was that, hey, 6 comes from 3 times 2. And there was a whole bunch of other ones, and you gathered this, and that is exactly right. That's the pattern I wanted you to find. Then we also uncovered that the exponent, there is what happens to the exponent here, and in every case in our example, just going back real quickly, in every case, see, the 2 became a 1. The 1 became a 0. This is x to the 0 because it's a constant there, and so on. That, skip that one. 3 became a 2. 1 became 0. See that? So you subtract 1 from the exponent. So this is actually 6x to the 1, but we wouldn't write 1. Okay? So, another one, negative 12x cubed. What's the derivative of that? So again, this is the function. The expression for the instantaneous rate of change at any point x would be negative 36, because that comes from 3 times negative 12. And then x to the power of what? Well, 3 minus 1 is 2. Okay, so there's your derivative there. So the derivative of this equals that. The derivative of this equals that. So the power rule stated, and I didn't want to get to the definition of the power rule because it's maybe a little confusing, but if you have x to any power, and this is going to actually be any power, not any power actually, n has to be a positive integer, so it doesn't work if n is, this whole rule doesn't work if n is 0, and I know we talked about if n is 0. That's the constant rule actually. If n is 0 or negative, this one doesn't work. But if you've got any power like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up. So the power rule is this. What we do is you would multiply the exponent, which here is n, right? So n times x, and it'll end up to be to the power of n minus 1. This is the power rule right here. And this is for n that is really greater than or equal to 1. Now I know we took a look at back up here. If I just back up here for a second, I know we said, hey, here's a 4, and that's like x to the 0. 0 times 4 is 0, and so on. Yes, that's true, but you don't subtract 1 from the 0 exponent. So that rule really doesn't apply to constants. That's why we have a separate constant rule. Okay, does that make sense? Maybe not. Anyways, so these are the 3 rules I wanted to focus on here today, and you guys uncovered those yourselves: the sum difference rule, power rule, and the constant rule. Okay? So I'm going to give you a couple just to do on your own, and you can have a little bit of practice with that to see if you know what you're doing. Okay. Find the derivative of the following. 2x squared plus 3x minus 10. And you can put the derivative right underneath. You do not have to use formula 1 or 2. You can use the rules that we've already been talking about. So there's the first one. So notice now, if you have a few simple rules, you could find the derivative of a really big, long polynomial. Can you imagine using formula 1 or 2 on this one right here? I mean, you would be destroying a whole tree with one question. Like a plus h to the power of 9. Sure, let's expand that one. And then to the power of 5 over here. And then, oh yeah, by the way, to the power of 3 and to the power of 2 over here. Go ahead, expand that. Gather all like terms. Take an h out, divide that out, then plug h in for, you know what I mean? So now, look at the fun we can have. Okay? Okay, so take a minute and do those two. Little chance to do this on your own. If you haven't, this is what you're doing. If you're stuck, again, 2 times 2, 4. X to the power of 2 minus 1, 1. Okay? 1 times 3, 3. X to the power of 0. Boom. Done. Why am I done? Because this is a constant. Constants just end up to be 0. So you don't even worry about the constants. It doesn't matter. This one here, go a little faster. 5 times 9, 45. X to the 8. Minus 15. X 4. Plus 12x squared minus 4x. Boom. Done. Okay, did you guys get that? Yes? Awesome. You are ready for the next level. Some of these questions from several sections. I need to go back and amend this power rule here. Whoops, where was it? When we talked about the power rule, I thought I was only going to give you questions with positive integers. But the general power rule, basically n is any real number. So with these negative ones here, you can still do the power rule. So do power rule. It's actually later in the book called the general power rule. So I'll even do this one for you really quickly. The derivative of this, you just follow the power rule. It's negative 4x to the negative 5. So you still subtract 1 even if it's negative. Okay? So that's the derivative there for that one. So that's what you're going to have to do at the end there. So when we talk about the power rule, yes, you can use the negative values. I guess the only place where the power rule really doesn't work is if we have like a constant, right? Then it's a bit different because this is 0 times 4, yes, is 0x, but it's not x to the negative 1. I mean, 0 times x to the negative 1 still gives you 0. But I don't want you to get confused that there's any kind of 1 over x or anything comes out of this. So technically, if you got the 0 in front, that just negates everything. It just makes everything 0. But you know what I mean? I just don't want you to get confused with that. So you can use the power rule for positives, negatives, fractions. Yeah, anything. So this one right here is, okay, you've got a 1 there, right? The power rule, taking the derivative of this, it's negative 1/2 x to the, what's this minus 1? It's negative 3 over 2. Because 1/2 minus 1, that's 2 over 2, see? That's negative 3 over 2, see that? So yeah, the power rule does work. Just wanted to start you off with positive integers, but even with negative integers, even with rationals there, fractions, it does work as well. So you can use the general power rule for all of these questions in your assignment. Have a good day.